Hello there and welcome back. So here we are going to develop the data structure linked list on our editor using Python. And we are not going to develop any linked list but the singly linked list. What is a singly linked list? When nodes are linked by a single pointer, by a single connection, we call them singly linked list. When the linkage between the nodes is single. We also have doubly linked list. But so far, in general, our understanding about the linked list is that they are single because we have so far seen just the single linked list. And that is quite okay because that is the standard one. And when people talk about linked list, they generally mean about the singly linked list. So here we are going to develop the code for singly linked list. And when we are thorough with it, we might want to get into the double linked list. We will discuss it and also look at the coding aspect, and if time permits we will actually code it on our editor as well. So without any delay, let's begin with the singly linked list coding aspect where we will be developing the data structure. So a linked list in general has two basic necessities. One is the value it stores and the other is to the next node that it points. So what we are going to do is we are going to store the data or value in the variable val, and we are going to store the pointer to the next node in the variable next. Now I will define a class node, and this node class will contain basically the two variables. So I will initialize the constructor function, which as an argument will take the val, and what it will do is it will set the object val as val and the object parameter next as none. So we have a node which is pointing to nothing but has a value of whatever the user or whatever we have inserted while initiating the object of the class node. Now that we have the basic building block that is required by our data structure linked list, and that basic building block, by the way, is the node, because linked list is nothing but the interconnection of nodes, and once we have the nodes, you get the point, right? We have the basic building block. So now we can begin coding with the linked list. So I'm going to create the class, and actually these braces are not required in the class definitions in Python, so I'm going to remove them. And what we will do is we will begin with the constructor function, and in the constructor function we will define the object properties. So if I instantiate an object of the class linked list, it should have a head, and by default it should be none because the linked list is empty by now. It should have a tail pointer, and it should be none because linked list is again an empty list right now. And it should have a property of length, how long the linked list is. And again, at the time of instantiation, it should be 0 because it is empty. Now, to begin programming with inside the data structure, we need to make some standard functions which will perform the operations on a linked list. At this point, this linked list is empty. So we need functions that will append values, push values at the end of the linked list, push values at the head of the linked list, maybe insert in between, functions that will return values from the linked list, that will pop values from different positions of the linked list. So we need to define those functions, and using those functions we'll be able to construct a linked list. And once we have constructed a linked list, we can traverse it. So I'm going to start from the very opposite end. I'm going to first define the function that we will use or one can use to traverse the linked list. So I'm going to assume that a linked list is uh, structured and created a proper linked list of n elements and nodes. And how do we traverse the linked list once it is there? We do not have any idea how it's coming into existence, but we are going to explore how we can traverse it. And the reason why I'm starting from the opposite end is actually it will give you a strong fundamental understanding of how we are manipulating the pointers on a linked list. Once we have that, we can proceed with the difficult functions, that is inserting, pushing, and popping. So I'm going to create a function by the name traverse, and as an argument it will take nothing, just the self, because it is an object of the class. So what we will do is we will define a current variable and set it to point at the head of the linked list. And we will use this current variable to traverse throughout the linked list from the head to the tail. And we will do this inside a loop while current is not equal to none. That is, while current is not none, while current is something. What we want to do is we want to print the value. So I'm going to print value of current dot val, because current is a node and dot val stores the value of that node. And then I'm going to move my pointer from current to current dot next. So what happens is, if I have a linked list of four nodes, 0, 1, 2, and 3, and the head is at the very first node, that is 0. The traverse function sets the current as pointing to the head, and what it will do is it will print the value of the current, which is by now head, and then move the current to the current dot next. So for when we are at the head, the current dot next is the next element. So we print the value of the current and then set the current to current dot next. So the current dot next now becomes 1, the node with value 1. And since this all of this is inside a while loop, and while current is not equal to none, what will happen is 1 will get printed and then current will change to current dot next, which by this time current dot next is the next neighbor of 1, which is 2. Now the current becomes the node current points to the node with value 2. It will get printed because again the loop is going to execute itself, and then current becomes current dot next, that is 3. And now this current is at the tail. So what will happen is the value of the current node will be printed, and then current becomes current dot next, and current dot next, the next node that tail is pointing to, is none. So current becomes none, and the moment current becomes none, our condition for the loop while current not equal to none is false. So we get out of the loop, and in doing so what happened is we traversed the entire linked list and in fact also printed the values. So printing the value was just for our human understanding, but the aim was to traverse the linked list, and we did that. I'd like you to pause the video for a second and look at this diagram or at this figure and try to understand exactly what is happening at what instance of time. I want you to understand precisely what is happening and when it is happening. I want you to go through the loop and have a thorough understanding of the entire traversal. So let's move on to our next function that is needed by our linked list. So starting with push, now the linked list is empty, remember. So we need a push function through using which we can push values to our linked list. So that is what we are going to do. Next up, we are going to create a function push that will take a value as an argument and push it, make it a node and push it to our linked list. So now I'm going to make that function. I'll call it push. What it will do is it will take from us the value val and make a node of it and push it at the end of the linked list, that is the append operation for arrays. So first of all, I'll create a node of that val and assign it to the variable new node. So I have created a new object of the class node. So I have basically created a new node with value, whatever the value that was given as an argument to the function push. Now there are two cases. If the head is none, that is if the linked list is empty. In this case, what I want to do is I want to make this node as the only node on our linked list. So this node will be the head of the linked list and also the tail of the linked list. Because you get the fact that if there is no head in the linked list is empty, and if the linked list is empty, this is going to be the only node, so it has to be the head and the tail. So self.head is equal to new node, self.tail is equal to new node. Otherwise, if that's not the case, what I want to do is I want to perform the append operation. That is, I want to push this node at the end of the next to the tail. That is end of the linked list, that is next to the tail. So self.tail.next, which was previously set to none, is now going to be set to new node. Not just that, what I want to do is I want to update the tail. So self.tail.next is the new node and the new node is the new tail. So self.tail is equal to new node. And so with this we have pushed a new node with a new value to our linked list and thereby incrementing the length of the linked list whatever it was by 1 because we have appended one node. So I'll do that, that is self.length plus equal to 1. Now to make sure you understand properly, have a look at this figure and just try to go through and understand what we did. It's all there. So now let's proceed. The next function that we are going to code is push head. It is going to take as an argument a value, make a node of it, and then push that node on the front end of the linked list. That is, this new node is going to be the new head of the linked list. So what this function is going to do is add at the side of head. And that is that is the front. So first of all, I'm going to make a new node. This is just a pointer that is pointing to the new node, and we create that new node by creating an object of the class node with the corresponding value. Then if self.head is none, again the case where um, where the linked list is empty, right? So in this case, as we discussed earlier, the new node is going to be the new head as well as the new tail. So now I'm going to just update the self.head and self.tail parameter to new node. Otherwise, which is the more common case, what we will do is new node dot next is equal to self.head. So this node now points as the next node to the head. So this places the new node before the head, and the other thing is we need to update the head parameter of the linked list object to new node. And of course, the self.length should be incremented by 1 because again the length of the linked list has been increased by one node. Now I am going to skip the diagrammatic representation of what we just did for this part because I believe it is very similar to the previous push function. So I'll just proceed with the next function, that is going to be the pop function. And by default, if we do not pass as any argument, the index is going to be -1 or key. Let's call the index as key. So the intention is if a user calls out to the pop function without passing any argument, what it will do is it will pop the last element from the linked list. But if the user specifies a specific index, let's say 0, that is the front, or any index 2, 3, whatever the index the user wants to remove from the linked list, if he decides to specify that while making a call to the pop function, what will happen is we will pop that specific node at that specific position. Otherwise, we'll simply pop from the end of the linked list, similar to what we do in arrays. So I just picked the analogy from there and we are going to code for that. So let's start with the base condition. If there is no linked list, that is if the linked list is empty, that is there is no head, if self.head is equal to none, return. That is there is nothing to pop from, right? If that's not the case, we can proceed. I'll declare a temporary variable and make it point to the head. And then I'll check if the key is equal to 0. That is if we want to remove the head itself. If that is the case, what we will do is we will make self.head is equal to temp.next. What I'm doing is I'm shifting the head rightwards by this line, and once that is done, what I will do is I will decrement the length by 1 since we are popping, and if self.length equal to 0, if by this popped operation the length of the linked list became 0, what I want to do is self.tail equal to none. I want to update the tail because if the linked list is empty, there is no more any tail. And then I want to return the popped element, which is temp. So this, I am just returning the popped node here. Now, if the key is greater than self.length, which means that we are asking to remove a node at an index which is larger than the length of the linked list. It's not possible, right? So simply return. The next case that we are considering is popping from the end of the linked list. So that means that the key is equal to self.length minus 1 or just minus 1. So if key is equal to self.length minus 1 or key is equal to minus 1, what this means is we are popping from the end, and the way to do that is we will make a loop where which will continue as long as there is temp dot next, and inside that loop we will set the previous prev to temp, and temp is equal to temp dot next. We will keep iterating over these two variables inside this loop until and unless we reach the end of the loop where temp dot next is none. And at that point, what we will do is we will come out of the loop and execute these lines of code. That is, we will set previous dot next to none and self dot tell to previous. So this way we have basically inserted a new tail, updated a new tail. Now for the general case where we want to pop a node from the linked list, which is not the head of the linked list nor the tail of the linked list, but any node in general between the two, what we will do is we will execute this else block where we are going to code for that case. So what we are going to do is for I in range key, we are going to loop and reach that index from the head. So what we are going to do is similar to what we did before. Previous is equal to temp, temp is equal to temp dot next, and we are doing it inside a loop in order to reach that index and also access the previous node to that index. And what we are going to do is previous dot next is equal to temp dot next, basically excluding the temp that lies in between, breaking the connection between them, and thereby popping it out of the linked list. So now the temp is no more present in the linked list because the previous dot next points to the temp dot next, which leaves temp outside the block, and by the dynamic allocation of the memory, this will scope out and be deleted eventually. Now for both the cases where we are popping from the end or from between, the length of the linked list is decreasing by 1. So outside the if block, what I'm going to do is decrement the length by 1. And then I want to make sure that if the length has become 0, which means by these popping operations, the linked list became empty. So I want to update the head and tail parameter here. I will set the self.head to none and also update the self.tail to none. So yeah, we need equal to here for the condition. So I was just looking out for what was wrong there. Okay, got it. So self.tail equal to none. And at the very bottom, we want to return temp, which is the popped node from the linked list. So that is what a pop operation does, right? It pops the element from the data structure and returns the popped element. So we have very efficiently developed the pop function, which when called by the object of the linked list will perform the pop operation. So there are basically a couple of more functions that a linked list data structure requires in order to perform function fully. One of them is get function, which is basically going to take the index as an argument and go and go to that specific index on the linked list, starting from the head using the traversal probably. And when it reaches that node, it will return the value of that node. There is another function for that is set. What this function will do, so for now I'll just pass the function calls, the function definitions. So this self set function is going to take the argument from the user as index and value, and what it will do is it will go to that index, and whatever the node value is, it will change it to the change it with the value that is inserted in this function. Other function is insert. What this function will do is insert a new node after the index that is mentioned in the argument of the insert function. So this is basically going to insert a new node between the nodes. Again, I'll pass because these are the functions that probably I'd like to take on in the another video, because by looking at the time it's already 20 minutes plus, so it's better that we split the video. So for now we have the basic functions defined, the push function, the pop function, and the traverse function. We have other functions which we haven't which we haven't coded yet: set, get, insert. We will do them later, but for now let's test the functionality of our linked list. So I'll create an object of the linked list as L, and now this is an empty linked list, so I need to push some values. So I'll make a call to push function and push some values. I'll push 1, I'll then push 2, then I'll push 3, then I'll push 4, 5. I think it's enough. And now I'll make a call to traverse function. Let's run this function and see what happens. Well, I get the output as 1, 2, 3, 4, and 5. So that is what the traverse function was doing. It was traversing from head to tail, and every time it is traversing from head to tail, it is printing the node values while doing so, while it is traversing from head to tail. So we get in order 1, 2, 3, 4, and 5. Let's test the pop function. So what I'm going to do is make a call of pop without any arguments. So it should pop from the end. And yes, the 5 has been popped from the linked list. Now let's pop from the front. So I'll pop an index as 0, that is pop the head. And yes, the node with value 1 has been popped from the linked list. Now let's pop the node at index 1. Error. Okay, so it shouldn't be 1 in the traverse function call, but in the pop. I should pop that argument. So it was a mistake. I'll run, and the node at index 1, the node with value 2 has been popped. So we have tested the push function, the pop function, and basically let's now test the push head function. And remember, push head does a pushing operation on the head side, that is on the front side. So I'll comment out the pop operations, and what I will do is I will push 0 to the head side of the linked list, and not just that, I will also push -1 to that linked list as well on the head side. I'll run the program and see we have -1, 0, so we have the linked list with the new head starting from -1. So the push head function is also working just fine. Now for better readability of the print statement, what I'm going to do is I'm going to modify the print statement. Instead of printing values on the new lines, what I want to do is print values followed by the arrow sign, just like showing a link pointer, the link between the nodes. So we have a linked list starting with -1, ending at 5, and going all the way as we traverse, and then 5 pointing to none. So this is our linked list. We developed it from the very scratch, and in doing so we had to understand how to manipulate the pointers, and that gave us a strong perspective and insights into the data structure. In solving the problems, this is going to be a huge plus point. Thank you for watching this video. The code for this data structure is in the description of this video. I hope you liked it. Give it a thumbs up, and that's it. Thank you.